the n term, and the n term denoted by t subscript n, is equal to 3n squared minus 2. Show that the first term of the sequence is 1. Right? So the n terms rule to find the n term, 3n squared minus 2. So show that the first term is of the sequence is 1. To get the first term, we substitute n equal to 1. To get the second term, n equal to 2. Third term, n equal to 3, and so on. Alright, so on the first term, so replace n with 1. So t subscript 1, first term. So 3 times 1 square, replacing n with 1, minus, 3n squared minus 2. Alright, that's it, 3n squared minus 2. So 3 times 1 square minus 2, which means that 1 square is 1, 1 square is 1 times 1, and times 3, that's 3, minus 2. So the first term is equal to 1. The third term is t subscript 3. So this time we're replacing n with the number 3, right, for the third term. So 3 times n squared become 3 times 3 squared. So we're using the same formula here. Minus 2. And then 3 times 3 squared. 3 squared is 9. 9 times 3 is 27. So 27 minus 2. So the third term is 25. So given that t subscript n, the n term is 145, what's the value of n? So which term we're asked, basically they're asking us which term is equal to 145. So remember the tn, you recall that tn is 3n squared minus 2. So we replace t subscript n with 145. So t 145 equal to 3n squared minus 2. So now we're solving for n squared, so we can add 2 to both sides. Alright, what will happen now? We have 3n squared equal to 2 plus 145, that's 147. And we divide both sides by 3. So n squared is 147 divided by 3, which is, so if n squared is equal to 145, then n is square, n squared is equal to 49, then n is the square root of 49. So n is 7. So in other words, the seventh term is 145. If you sub n equals 7 into this formula here, 3 times 7 squared minus 2 will give you 145. The next question, the first 8 terms of another sequence with n term are, this seems to be the Fibonacci sequence, 1, 1, 2, 3, 5, 8, 13, 21, and so on. If you notice how we're getting the first terms, you add the last 2 terms to get the next term. You notice that pattern here, you'll see that, so to get the 5th term, you add the 4th term and the 3rd term. To get the 7th term, you add the 6th term and the 5th term. To get the 8th term, you add the, to get the 8th term, you'll add the 7th term and the 6th term, and so on. So, write down the next 2 terms in the sequence. So let's look at how we're getting the terms. So you add, so 1 plus 1 give you 2. Then to get the next term, let me just start it from scratch. Alright? So 1 and 1 are the first 2 terms. So to get the next term, you add 1 and 1, you get 2. To get the next term, you add 1 and 2, you get 3. To get the next term, you add 2 and 3, you get 5. To get the next term, 3 and 5, you get 8. To get the next term, 5 and 8, you get 13. To get the next term, 8 and 13, 21. So to get the next term, so 1, 2, 3, 4, 5, 6, 7, 8. So we have up to the 8th term. So the ninth term would be the 8th term plus the 7th term. So the 9th term would be 13 plus 21. The 8th term plus the 7th term, which is 13 plus 21. What's that? 34. So the 9th term will be 34. And the 10th term will be the 9th term. So it's always the 2 last terms. You add in to get the next term. So the 10th term would be the two last terms, you know, would be 21 and 34. Or 34 and 21, whichever one you want to put first, since addition is commutative. So that's 55. So the 10th term is 55. And the 11th term will be 34 plus 55 and so on. So U9 is 34, U10 is 55. Next, we're asked which term in the sequence is the sum of the 18th term and the 19th term. And the answer is that will be the 20th term. Alright? The 20th term is the sum of the 18th term and the 19th term. So here we have a proof, show that the 20th term minus the 19th term is equal to the 19th term minus the 17th term. Okay? So, let me deal with the left hand side first. So the left hand side is the 20th term minus the 19th term. No. The 20th term, what's the 20th term? The 20th term is the 19th term plus the 18th term. And then we have minus U19, minus the 19th term, so it's a substitution. And then, so these cancel, so we are left with just the 18th term. Let's deal with the right hand side. On the right hand side, we have a 19th term minus the 17th term. And the 19th term is the 18th term plus the 17th term. And then now we'll put back this 17th term for substitution. So these cancel, so we're just left with the 18th term. So the left hand and the right hand side both have the 18th term, so the left hand side is equal to the right hand side. So therefore, what we set out to prove was proven, or is proven. Question 8. State a value of x that cannot be in the domain of f. Remember, domain of f will be all the possible x values. Now remember that we cannot divide by 0, so the domain is 2x plus 1. 2x plus 1 cannot be equal to 0. So if we should transpose here, subtract 1 from both sides, we have 2x cannot be equal to minus 1. Hence, divide both sides by 2, x cannot be equal to minus half or minus 0.5. Makes perfect sense, because if you replace x with minus 0.5 or minus half, 2 times minus half will give you negative 1. Negative 1 plus 1 is 0. You'll end up with 9 divided by 0, which is undefined. Alright, so x can be any value except minus a half. So now we are asked to find fg of x in its simplest terms. So if fg of x means you substitute g into f, meaning in f, here's f, in f is 9 over 2x plus 1. So wherever there's an x, you're going to replace it with the function g, and g was what? G was fx minus 3. So you're going to replace x with x minus 3 in the function f. So the function f is 9 over 2x plus 1, but we're replacing x now with the g function, which is x minus 3 plus 1. And I guess we could simplify this a little bit. So this is 9 over, we expand, we get 2x minus 6, multiply 2 to both terms in the bracket, 2 times x, 2x 2 times minus 3 minus 6, plus 1. So you will end up with 9 over 2x, and then negative 6 plus 1, that's negative 5. Next, we are asked to find the f inverse x. So we let y be equal to whatever f of x is, which was 9 over 2x plus 1. And then we interchange x and y. Meaning where we have a y, you replace with x. And wherever x, you replace with y. Over that, and we can multiply both sides by 2y plus 1. So here we get x times 2y plus 1 equal 9. So we expand the bracket, x times, just make some space here, expand the bracket, x times 2y, that's 2xy, x times 1, that's 1x, equal to 9. So we want to transpose now for y. So to subtract x from both sides, we end up with 2xy equal 9 minus x. Remember, you're transposing for y, so divide both sides by 2x. So y is 9 minus x over 2x, and of course whatever you have for y, that is your inverse function. So f inverse x is 9 minus x over 2x. The diagram below shows two rectangles, ABCD, as we can show, is a larger rectangle, and inside of that rectangle now we have GFED, and we are told ABCD has an area of 44, so the entire area is 44 centimeters square, and GFED has sides 4 and 2, as we can see there. AG is equal to EC, so AG, this length, is equal to EC is equal to 3x. By writing an expression for the area of rectangle ABCD, show that x squared plus 2x minus 4 is equal to 0. Now, the area, I'm going to put it here, the area of ABCD, we are told is equal to 44 square centimeters. If I should use this shape here, of course the area, if it's a rectangle, so length times width. So notice the length, or the length with one side is 3x plus 4. So this length, 3 to here, a to g x, 3x, and here to here 4. And then the other is 2 and 3x, or 3x plus 2. So if you take the product of these two sides, so one side 3x plus 2, one side 3x and 4, and the area, length times width, should give you 44, right? So we should simplify this, and we expect to get x squared plus 2x minus 4. Let's simplify. So we expand. So 3x times 3x, that's 9x squared. And then 3x times 2, that's 6x. Take the 4 now, 4 times 3x, that's 12x. And 4 times 2, that's 8, equal to 44. Alright, let's group like terms. So we have 9x squared. If we group the 6x and the 12x, we get 18x. And then this 44 here, we can group the constants with minus 44 equal to 0. So we have 9x squared plus 18x minus 8 take away 44 now. That's 36. Negative 36. And then to simplify, notice each term can be divided by 9. So we divide each term by 9. This term divided by 9, we get x squared. 18 divided by 9, that's 2. And negative, well, 18x, so 2x. And minus 36 divided by 4, divided by 9, sorry, that's minus 4. So we divide each term by 9, we end up with that. And so we've shown the expression can be reduced to x squared plus 2x minus 4. Now the next thing they wanted was just for us to calculate the value of x squared plus 2x minus 4 equals. Now you can do this we can do this several ways. We can use the formula, the quadratic formula, x equal minus b plus or minus b squared minus 4ac over 2a, and you use 1 for a, 2 for b, and negative 4 for c. Or you could factorize. If you factorize in x squared plus 2x minus 4, you can rewrite the positive 2 as 4x minus 2x and minus 4 equals 0. And you factor by groups. For the first pair, x into x plus 4. And the second pair, minus 2 x plus 4. So the factors will be x minus 2 and x plus 4. Now, since x has to be a positive value, because the length of a side cannot be negative, so you equate both brackets to 0. But this is the only one we'll use. X minus 2 equal to 0, and therefore we transpose or add 2 to both sides. X equal to positive 2. That's our value for x. And the final section to this question was to find the perimeter of the unshaded region. The unshaded region would be, I guess, this unshaded region would be this region. The perimeter for the unshaded region. Now the perimeter for the unshaded region, unshaded region would be, let's check it now. So let me do AB first. AB is the same thing as DC, which is 2 plus 3x, right? So 2 plus 3x, if we add that side, if we add, let me move in a clockwise direction. BC is what now? Same as AD, which is 3x plus 4, plus, and then this length, EC, which is 3x, plus FE, which is same as GD, 4, plus GF, as GF, 2, same as DE, 2, plus AG, and AG is 3x. Now remember that the value of x is 2, so we're going to substitute 2 and calculate the perimeter. So we have 2 plus, remember x is 2, so 3 times 2, that's 6, plus 3 times 2, that's 6, plus 4, plus 3 times 2, that's 6, plus 4, plus 2, plus 3 times 2, remember x is 2, x is 2, so 3 times 2 is 6, and we add all those values, in the end we should get, it seems like 36, and the units, centimeters, 36 centimeters. Now the penultimate question, question 9, the first angle we were asked to calculate given the reasons was angle DBA, a circle theorem problem. DBA is which angle? DBA, so that's this angle that we're asked to calculate. Now we know there's a theorem that says, now here's diameter AC, notice AC runs through the center of the circle. So AC would be a diameter of the circle. So notice the angle formed from the endpoints of diameter. So that angle will be B, the angle formed from A and C. There's a circle theorem that says this angle is a right angle or 90 degrees. Alright, so whatever this angle is DBA, so angle 46 plus angle DBA, which is this angle in question that we want to find, plus angle DBA should be equal to 90 degrees. Why? These angles are, this angle, this entire angle should be a right angle, because this angle was formed from the endpoints of the diameter AC. So the summation here should be 90 degrees. So subtract 46 from both sides. That means angle DBA is equal to 90 minus 46, which is what? 42. So this angle should be 42 degrees. The next angle that we're asked to determine was angle DAC. So this was part 1. Part 2, we're asked to determine angle DAC. DAC, so D to A to C. So we're talking about this angle. Now I did playlist on the circle theorem. So please be sure to check out those videos. Now there's a theorem that says, now here's a chord. DC is a chord. Notice the angle formed from DC, the endpoints of this chord DC here is 46. The angle formed on the circumference here. So any angle formed from the chord, from the endpoints of the chord to meet on the circumference, is always equal. So here's again from the endpoints of this chord here DC, The angle here formed is A. So two angles are formed from the endpoints of DC. Angle B and also angle, that's angle DBC, which is 46, and also angle, this angle, angle A, angle DAC. So angle DAC would be 46 degrees. Alright? Since it's coming from the same chord DC to meet at the circumference. The third angle that we're asked to calculate, given the reasons, is angle BCE. BCE, so BCE, that's this angle right here. Now we can take several approaches to this problem. You notice if we consider triangle ABD, remember all triangles, some of the angles, that's 180. So this is this angle, that's 46 plus 28. So this angle, in angle ABD, this angle would be, all of this would be 74. All of that would be 74, right? Plus 42. And that will give me 116. So this angle will be 180 minus 116. So this angle will be 64. Does that help us? Let's see. So we're talking about well, maybe not. Let's look at this angle, this triangle here, A, B, and this triangle here. Notice this is 42, this is 28. What's 42 plus 28? 70. Angles in a triangle must add to 180, so this will be 110 degrees, which means the opposite angle here would be 110 degrees. Also, alright, which other angle can we get now? I guess we did some unnecessary work here. Notice the chord BD. The chord BD form an angle on the circumference, angle A, and which is 74. So this angle and this angle would also be 74 degrees. So also be 74 degrees. So remember, angles on a straight line add to 180. So angle 74, so all of this angle here, plus BCE should be equal to 180 degrees. So 74 plus this angle must be equal to 180. Angles in a straight line add to 180. So if I subtract 74 from both sides, BCE will be 180 minus 74, which is what? 106 degrees. Error was made here. Just make the correction. What we have here, A, B, C, D is what we call a cyclic quadrilateral. So the opposite angles, some of the opposite angles must be equal to 180. So angle A, all of this angle, which is 74, must be 74. All of this angle must be the sum of this angle A, all of angle A, and this angle here BCD must be equal to 180. Let me just write this. So this angle will actually be 106. All of this will be 106 degrees. Alright, so 74 plus 106, these two angles must add to 180. So angle BCE, remember angles on a straight line add to 180. So this 106 plus this angle BCE, so 106 plus angle BCE must be equal to 180. Alright. BCE must be equal to 180. So which means BCE would have to be 74 degrees. So this angle would have to be 74 degrees. So in part B we have a quadrilateral here, PQRS, and we are told that PQ is parallel to RS. So this angle will also be 90 degrees, since these two lines are parallel. So if this is 30, then this angle would be 60 degrees. Now we are asked to find the length of PS. Of course, this angle would be 30 degrees. Putting all line and no angles. All angles in a triangle are to 180. So this angle would be, angle R would have to be 68 degrees, since all the angles are to 180. Not sure if we'll be needing all these angles, but just fill them in anyway. So the length of PS, we're talking about this length. We could use, now notice, if we're referring to this angle 30, this 30 degrees, then PS would be the opposite. So of course we can use a sine ratio since it's a right angle triangle. So remember sine theta is opposite over hypotenuse. Alright, so sine, let me use a 30 degrees. Sine 30 is opposite, which is what PS is, the opposite, over the hypotenuse. And what's the hypotenuse? 8. So opposite over hypotenuse. So of course to get the PS we can times both sides by 8. So times the right hand side by 8, it cancels. So we're left with PS, and then the value of 8 times sine 30 is 4. So PS is actually 4 centimeters. Now in part 2, we're asked for the length of PQ. So part 2 was the length of PQ. That was part 2, right? The length PQ. PQ, that's this length. And of course you could use several means. You could use Pythagoras Theorem, since you're talking about a right angle triangle here. So we can use Pythagoras Theorem, which says the sum of the two short sides square is equal to the hypotenuse square. So Pythagoras Theorem, let me call it PQ. So 4 square plus PQ square is equal to the hypotenuse square. So opposite square plus adjacent square equal to hypotenuse square. Alright, and the hypotenuse, that's 8, so 8 square. So 4 square, that's 16, plus PQ square is equal to 64. So subtract 16 from both sides. PQ square is equal to 64 minus 16. Or 64 minus 16 now? 48. So PQ square is equal to 48. So PQ will be the square root of 48, which is 6.93 centimeters. So PQ, this would be 6.93, rounded off to the nearest, rounded off to 3 significant figures. And of course, you could also use one of the trig ratios to find the length of PQ, since it's part of the right angle triangle. Next, we're asked to find the area of the quadrilateral PQRS. So to find the total area, I guess you could take several approaches. I guess you could find the area of the PQRS triangle and then find the area of the RQS triangle. Either way, you will need to find the length of this side, RS. And of course, to find the length of RS, you could use a sine rule. Now the sine rule, so sine 82, sine the angle over the opposite side, which is RS, is equal to sine another angle, so sine 68 over the opposite side, which is 8. Alright. And we could, I guess you could cross multiply. You have RS sine 68 equal 8 sine 82. Remember, you're solving for RS, so you need to divide both sides by sine 68. So into that. So RS is equal to 8 times sine 82 divided by sine 68. So 8 sine 82 equal divide by sine 68. It's 8.54 if I'm using three significant figures. So it's 8.54. So this the length of this side, RS, is 8.54 centimeters, and of course the height, this height is the same thing as PS. The height of this triangle would be 4 centimeters. So area, so the total area of the shape PQRX, the total area, the area of the triangle PQRS, could use half base times height, use 4 as a base, 6.93 as a height. So half base times height, so half, times I'm using 4 as the base, and 6.93 as the height, plus the area of this triangle now, RQS, half base times height. So again, the base is RS, the base is RS, so half times 8.54 times height, and we talk about perpendicular height, which is the same as PS. So the perpendicular height would be 4. So the value of this would be the calculation. So 0.5 times 4 times 6.93 plus 0.5 times 8.54 times 4 is equal to 31 to the nearest whole number. So 31 to the nearest whole number. Well, 31 square centimeters, right? To the nearest whole number. Because I talk about area, so cm square. So that's question 9. Question 10, the matrix product. So we're multiplying the matrix. So remember, row is row by column, first term by first, and second by second. So row by column. So the first row, negative 1, 3 to k5. So negative 1 times k, that's negative 1k. Plus 3 times 5. So let's put it here. So negative 1 times a k plus 3 times a 5. So negative 1, and then what we'll have in here below now. So the next row by the same column, 4h times k5, so 4 times k plus, just erase this, plus h times 5, or so 5h. Right? So this will go what now? Negative k plus 15, or 15 minus k if you want to put the positive value first. And this is what? 4k, or 4k plus 5h. So that would be your matrix product. Because you're multiplying, this is a 2 by 2 matrix. And k5, that's a 2 by 1 matrix, because it's 2 rows and 1 column. So you'll end up with a 2 by 1 matrix, which is what this is. Negative k plus 15, or 15 minus k, whichever. If you want to write it like that, that's fine. Or negative k plus 15 if you prefer. And 4k plus 5h, whichever. Alright. Now we're asked to find the value of h and k. Now remember the matrix product. Let me just rewrite it. Can just do it again. The matrix product, row by column, was negative k plus 15, and then we have 4k plus 5h, which means that corresponding term negative k plus 15 is equal to the top value 0. So we equate the top, and also here 4k plus 5h equal to 0. Now from this first one here, we can transpose, just add k to both sides. Alright, so 15 equal to k, or k equal to 15. Now since k is 15, 4k will be 4 times 15 plus 5h equal to 0. So 4 times 15, that's 60. So 60 plus 5h is equal to 0. Subtract 60 from both sides, so we have 5h is equal to minus 60. And then to solve for h, you divide both sides by 5. So 5h divided by 5, that's h. And negative 60 divided by 5, that's negative 12. Alright, so divide both sides by 5. Alright, you end up with that. So use matrix method to solve this equation, this pair simultaneous equation. So again, remember we can use ax equal to b, where x is the solution. A would be the coefficient of the terms of the x and y from the left hand side here. So A will be the matrix 2, 3, and it's negative 5. And remember y is 1y, so 1. This is just xy. Equal b, and b is just constants over here, 5, 13. So we can times both sides now by the inverse of A. We can times both sides by the inverse of this matrix. Now, the inverse of this matrix, inverse of the matrix, is 1 over determinant times the adjoint. Alright, so the determinant for this matrix, 1 times 2, which is what? 2. Take away determinant, let's write determinant here. The determinant for this matrix is 1 times 2, which is 2. Take away negative 5 times 3, that's negative 15. So the double negative, so the determinant is 17. Alright, so the inverse of A is 1 over 17 times the adjoint. And how we get the adjoint now? We switch the elements in the leading diagonal here. So 1 and 2. And then the other diagonal, we just change the sign of the element. So positive, negative 5 become positive, positive 3 become negative. So that's the inverse. So what we'll do now is times both sides by the inverse of A. So the inverse of this is 1 over 17 times 1 over 5 minus 3, 2 times 2 minus 5, 3, 1. So times that by its inverse. So times the left hand side by its inverse. And the right hand side, we times it by the inverse, the same thing also. So the same rule in algebra, multiply, or pre-multiply both sides by the same thing, which is the inverse of A. Alright, so notice what we did. We multiply both sides by this. Alright, by that. Now what will happen? What will happen now? All of this will become the identity matrix. When you multiply A inverse times A, what you get is the identity matrix I, which is 1, 0, 0, 1. Alright, and you can do the long expansion if you wish. And then over here, you have 1 over 17. Let's do the multiplication now. Row by column. So row by column. So 1 negative 3 times 5, 13. So 1 times 5, that's 5. And negative 3 times 13, that's negative 39. And then the other row, 5, 2, by the same column. 5 times 5, that's 25. Plus 2 times 13, that's 26. So we end up with So when you expand 1, 0 times 0, 1, you get back the same xy. Equal to 1 over 17. Now 5 take away 39, that's negative 34. And then 25 plus 26, that's 51. So multiply both terms in the bracket by 1 over 17. So 1 over 17 times negative 34, that's negative 2. And 1 over 17 times 51, that's positive 3. So therefore x equal to minus 2 and y equal to positive 3. And of course you can try these values in the simultaneous equation to see if you get back 5 and 13 on the right hand side. So x is 2. So 2 times minus 2, that's minus 4. 3 times 3, 9. 9 minus 4 plus 9, that's 5. So it works for the first equation. The next equation, negative 5 times negative 2, that's positive 10. Positive 10 plus y, which is 3. 10 plus 3, 13. So we are confident in our solution. So now we are at 10b. We are given some information there. So b is a 0.36, o is origin 0, 0, a is 9, 0, and we are told that D and E are on AB and OA respectively, such that AD is a third of AB and OE is a third of OA. And we see all of that in the diagram, and we're asked to find the following vectors. So the first vector we were asked to find was AB. So AB, vector AB, we can just write as B minus A. Alright, and B, what's B? 3, 6. And A, what's A? 9, 0. So 3 minus 9, that's negative 6. 6 take away 0, that's positive 6. So AB is minus 6, 6. We were also asked to find a vector OD. And of course OD would be from here to here, right? That's OD, and that's meant to be a straight line. OD. So to get from O to D, you can triangle law. We can go O to A. And then A to D. Alright. So which means that OA, we are told that OA is the position vector 9, 0, right? Or you say A minus O, which is still 9, 0. Now AD, remember AD, where's AD? AD is a third of AB. So AD, here is A, remember AD? Remember this? Right, so AD is 1/3 of the vector AB. It's 1/3 of AB. So here AB, remember we have AB, which is negative 6, negative 6, positive 6. So AD is 1/3 of that. 1/3 of whatever AB is, which is negative 6, 6. So it's 9, 0 plus 1/3 of each number inside. So 1/3 of negative 6, that's negative 2. 1/3 of 6, that's positive 2. So we add these two values. 9 plus minus 2, that's 7. 0 plus 2, that's 2. So the vector OD is 7, 2, right? The next vector we were asked to find was BE. And you can see BE, that's B to E. B to E there. So to get from B to E, you have two options, but I'll use BO plus OE. And BO, now OB was 3, 6, as we were told, OB, but we're going in the opposite direction. The sign changes. And then OE is a third of OA, and OA was 9, 0, so it's a third of 9, 0. So this is minus 3, minus 6, plus a third of each number. A third of 9 is 3, a third of 0 is 0. So we end up with negative 3 plus 3, that's 0. Negative 6 plus 0, that's negative 6. So BE is your negative 6. So there ended May, June 2019 past paper. All the very best. 2018 coming up soon.